In this video, we are going to build a machine learning model that predicts an employee's salary based on the age, gender, education, job title, and years of experience. So what we are going to do is that we will use multi-linear regression, visualize the data sets, and then train the model, and then even make salary predictions from custom inputs. So at the end of this video, you will know how to write the code, and you will also understand the logic behind it. So let's get started. First thing we do is to import all the required libraries. So let's import our required libraries. So now we have imported all the required libraries. So firstly, I have imported NumPy, which is used for numerical operations. Next, we have imported pandas, which is used for handling the datasets. And then we have imported matplotlib and seaborn, which are used for data visualization. Next, what we have done is from scikit-learn, we have imported train test split from model selection. And then we've imported linear regression from linear model. And then we have imported some metrics like mean absolute error and mean squared error and R2 score. And then from impute, we have imported simple imputer. Simple imputer is a class in scikit-learn which is used to handle missing data in dataset by replacing through some specified strategy. Now, before writing all the code, what we need to understand is that we are performing this using multiple linear regression. So let's understand something about multiple linear regression. Now, if you see my previous videos, you get to know that linear regression means finding relationship between x and y, where x is my dependent variable and y is my independent variable. Now in simple linear regression, we used to see that there was only one dependent variable which we want to find. Whereas in multiple linear regression, we have more than one input variables. So this is what we want to predict in multiple linear regression. Now the goal of multiple linear regression is to find the relationship between input variables and output variables. So relationship can be mathematically represented as y hat is equal to beta naught plus beta 1 x 1 plus beta 2 x2 and so on up to beta d and xt. So beta 1 through beta d are estimated regression coefficients for the independent variables x1 through xt. Now as in simple linear regression, the regression model to get actual variable is y is equal to beta naught plus beta 1 x1 plus beta 2 x2 and so on up to beta d xt, and then comes a residual called e. Now e is just my random error. Now, what E is exactly is that it reflects the difference between actual output point and the predicted output point. And so we can say that multiple linear regression involves more than one input variable. So we want to find them through appropriate solution. Let's get back to code again. I'm going to run this first cell, and the next thing I'm going to do is to load my dataset. So I need to copy the path of my dataset. So all I need to do is to go to my files, and then I have your salary data.csv, which I have uploaded it to my runtime. And all I will do is to right click and then give the copy path, and then I will just simply go and paste this. So this is my path here, and I will put this into string format. So once I've done this, I can go and view my dataset. And the next thing I'm going to do is to print my head, which is the first 5 rows. Now heads give the top 5 rows of our dataset. So as you can see in my dataset, there are age, gender, education level, job title, and years of experience. Now based on these parameters, we need to find the salary. Now let's go and find what are the basic information in our dataset. The first thing which I will do is to print my dataset info, which I can do using this function. So it's going to give my information in our dataset. So there are age, gender, education level, job title, and all those things. So they're like non-null, and data type is also mentioned there, which is float 64, and gender, education level, job title are my objects, and years of experience held are by floating point numbers. And you can also see the memory uses by this particular dataset. And let's see if there are any missing values in our dataset. So for that, I need to print df dot is null dot sum. So what it basically does is that it checks for any missing values if they are present. So let's now visualize our dataset. So I'm going to make a pair plot and a heat map for that. So let's go and then print that thing. So I'll just go and then write it following code sns.pairplot and put in the data frame in there. And let's use a super title for this. So plt dot super title. So let's take it as okay, pair plot of variables. And then we can finally show this thing. So you can see this is a pair plot. Now you can see that okay, this is not exactly aligned my super title, so I can position this the way I want to. So let's set another parameter called y, and okay, let's set it randomly to 1.02. So you can see my super title is perfectly aligned right now. And you can see this is my pair plot. So pair plot actually shows the pairwise relationship between all the numeric column in dataset. And this is often used in exploratory data analysis, which we commonly use as EDA to understand the patterns and the correlations between the features. So this is what our pair plot of this dataset looks like. So let's now go and visualize our heat map. So heat map is basically displaying my data in matrix form where value are represented by different colors. So for that, I will type the following code. First of all, I will set my figure size to 6 by 4. I'm setting my title as correlation heat map. And finally, I will go and show this. Okay, so it's like, it's my figure size. So you can see a correlation heat map out there. So it's like values are represented in the form of matrix. So there are my two of the visualizations that are pair plot of the variables and the correlation heat map of the variables, which are very important for the exploratory data analysis step. Now let's go and run this cell. Now let's move to other part of the code. Now what this line does is that it removes any rows with any missing values. So we can run this. The next thing we have is feature and target selection. So X are all the features which are independent variables. Now based on that, we predict Y, that is the salary. Y is my dependent variable and X is my independent variable. So we go and run this. Now the strategy we have used here to put the missing values is that we have used mean of all them. So the missing values are represented from mean of all the data sets. So we have used simple imputer function for that, and we have replaced them with the mean value. Next, we have trained a split. So it is very important step in machine learning as we need to split the whole data set into training and testing part. So for this, what I have done is that I have split the data set into training and testing set. Now you can see that X train, X test, Y train, Y test are my training and testing sets, and they are split into a size of 20% of testing size and 80% of my training size. And random state is set as to 42. So random state is set because to produce the reproducibility. So whenever I run this, I again get the same set of random numbers. Now let's go and run this thing. The next step is to train the linear regression model. So for that, I have fitted the model linear regression, and this is fitted using ordinary least square. So let's train this, and you can see that my model is being trained, and you can see the quotation has fitted, and you can also read the documentation for linear regression right from there. So it opens up the tab which have all the information in the linear regression section, and then we have finally printed the model coefficients. So it's like telling me how much feature affects the salary prediction. So positive actually means that I have an increase in salary, whereas negative means that there's a decrease in salary. So let's go and print this thing. So you can see that okay, these are my further coefficients, and there are like 170 rows and one column. So I have again printed my coefficients again. So next thing what I will do is that I will predict this on test data. So they are like predictions on unseen test data. So test data is basically hidden from our model. So let's go and run this thing. So now let's go and print the model evaluation. So model evaluation are like I have printed my MAE, MSE, and RMSE, as well as the RD score. So I have explained that in detail in my previous video, but let's now understand this in a very short way. So mean absolute error is like average absolute difference between actual and predicted values, whereas MSE is my squared version of ME. Now RMSE is square root of MSE, whereas R squared is the variance explained by model. So R square, as it is closer to 1, the better the model is. So you can see that my R squared is pretty good, and these are my model performance metrics. So after printing the model evaluation, what we do is that we visualize the actual versus predicted data points. So this figure actually shows that how close my predictions are to real values. So the second thing we have done is that we have calculated my residuals. So residual, as I said in my earlier part of this lecture, that it is the tested values minus the predicted values. So I've just created a histogram plot of this. So you can see that this is the plot of my residuals distribution, and this is what the residuals versus predicted values actually looks like. And the next thing I have written is the functions to predict the salary from the new input. So I've written this function, and then I can enter my own inputs and then predict the salary based on those. So let's go and finally predict my salary based on the input features. So for that, I go and simply write, okay, let's see an example of predicting how can we predict this final salary using all those input features. So I write to call the function predict salary, and I need to pass the arguments as my age, gender, education level, job title, and years of experience. So okay, let's go and get this. So age is okay. Let's put it as, let's keep it as 30, and I'm putting the gender as male. Okay, let's keep my education level. So I have bachelor's, master's, and PhD. So okay, let me keep it as bachelor's. Then let's calculate the salary of a data scientist. And okay, let's say the data scientists have 5 years experience. So years of experience is equal to 5. So let's estimate the salary based on these. So we can see that based on those given inputs, we can get a salary of 74,470. Now, what if I increase my years of experience? So let's see if it increases or not. So you can see that it has increased to 85,905 rupees. So that's working pretty good. So that is how you build your own salary prediction system using multiple linear regression. Now, please consider subscribing this channel so as to avail future tutorials as well. Thank you very much for watching.